Today we're looking at optimisation, and this is where we use differentiation to find maximum and minimum values. We're not thinking about turning points on a graph, we're thinking about these as values in real life situations. So what will be the maximum return for my investment? What is the minimum amount of packaging I can use to manufacture this product, etc. We're going to move straight on to notes, so we are on page 27. For these types of examples, in addition to our differentiation knowledge, we're going to be having to remember formulas that we might not have used for a while. So basic area formulas, volume, etc. In this particular case, we are looking at volume and area. So we're given a picture of a small wooden tray. It has an open top and a square base. They're being designed to have a volume of 108 cubic centimetres. We're given an internal length of one side is x and the internal height is h. And we're asked to show that the internal surface area of one tray is given by this expression. Now, the surface area of a three-dimensional shape like this is simply the surface area of each of the individual faces added together. Now, in these type of questions, don't be misled by the drawing. The base of this shape looks like a rectangle, but we are told that it's a square. We're told that the length is x, so the area of that bottom part must be x squared. The area of the front face, it's a rectangle, so it's going to be length times breadth, which will be x times h, and that will be the same for each of the four sides because it's on a square. So it's going to be x along and h high, x along and h high, x along and h high. So I'm going to have four of those. So that's where we're starting. So area is x squared, because that's the bottom, plus 4 lots of xh, because each of the individual sides is x times h, and there are 4 of them. There's no top, so that's us, got an expression for the area. Now in the question, it asks us to show that the area is equal to this. Now we've got the x squared, but we've got something quite different here. And the main thing to notice that's different is we've included an h here, and we don't want h. So we need to find another way of expressing h. So we're going to go back to the original information we're given and see if there's something else we're told. Now here we're told we've got a volume of 108 cubic centimetres. Now the volume of a cuboid is length times breadth times height, which in this case is x times h, or x squared h. The volume of this one is 108. So we know that 108 is the same as x squared times h. I'm going to rearrange this so that I can find a way of saying h in terms of x. So I'm going to divide both sides by x squared, and I get 108 divided by x squared is equal to h. And what I'm going to do is I'm going to replace the h up here with this new expression that I found for h. So the area is equal to x squared plus 4 times x times, in this case, 108 over x squared. I'm going to tidy that up a little bit. So x squared plus the x up here is going to cancel with one x is on the bottom, so I'm just going to do 4 times 108, which is 432, and I've cancelled out one of the x's, so I've just got x on the bottom. And now I've got the same expression that I was asked for in the question. When it's a proof question, I show that question. When we get the expression we were given, we just need to say as required. Now this type of question, the optimisation questions, tend to come with a part A where there's a proof and a part B where we're actually using that expression to calculate a maximum or minimum value. Part A generally is a little bit trickier, but you can do part B without being able to do part A because you're given the answer in A. Okay, part B asks us to find the dimensions of the tray using the least amount of wood. That means we need to find the minimum value. So we're going to be looking for a minimum turning point. We're going to differentiate, we're going to make it equal to 0, we're going to solve, we're going to use a nature table to check if that really is a minimum. Once we've concluded that it's a minimum, we'll work back to find the actual dimensions of the tray. Now before we differentiate this, we're going to have to do a little bit of preparation because I've got an x underneath a fraction there. So I'm just going to use my index rules to bring that up, and it will be x to the minus 1. Now I'm differentiating. I'm saying a dashed x because it's with respect to x. 2x minus 432 x to the negative 2. I'm going to tidy it up to make it easier to substitute into. So 2x minus 432 over x squared. We make it equal to 0 because it's for stationary points. And now I'm going to solve. It's difficult to find a factorisation at this point, so I'm going to just move the 432 over x squared to the other side. So 2x is equal to 432 over x squared. I'm going to multiply by x squared, so 2x cubed equals 432. I'm going to divide by 2. X cubed is 216. And I'm going to take a cube root. The cube root of 216 is 6. So I think that 6 is the value that x needs to be in order for us to have the minimum amount of surface area in this box. Now I'm going to just use a nature table to check that that is indeed the minimum. So I'm drawing my table the same as I did in previous examples. So I'm going to have x, I'm going to have a dashed x, and I'm going to have the slope. The minimum I think is 6. I'm going to check a little bit before and a little bit after. I'm just going to choose 5 and 7. Remembering that I'm substituting into the a dashed x, so I'm just going to put that down here. It's 2x minus 432 over x squared. So let's try with a 5. 2 times 5 is 10, minus 432 over 5 squared, which is 25, which is 250, take away 432 over 25. Well, I can see straight away that's a negative. It's minus 182 25ths. So that's a negative. For 7, 2 times 7 is 14, minus 432 over 7 squared, which is 49. Now this example is from a calculator paper. These tend to come in calculator papers, but they can come in both. So I'm just going to tell you the answer for this one is 254 over 49. You could use your calculator and you could get a decimal number if you prefer. That's positive. So my slope goes negative, stationary, and increasing. So in fact this is a minimum turning point when x is equal to 6. So now I'm just quickly reading the question again, and it says for B, find the dimensions of the tray using the least amount of wood. Well, the dimensions are length times breadth times height. It's a cuboid. The length and breadth on the bottom were both x, and the height was h. So length is equal to x, which is equal to 6 centimetres. Breadth is also equal to x, which is equal to 6 centimetres. Now for the height, we're going to go back and look at what we did in part A when we rearranged the volume, and we came up with an expression for h, which was 108 divided by x squared, which in this case is 108 divided by 6 squared, which is 36, and that is 3. There are 3 36s and 108. So the length was 6 centimetres, the breadth was 6 centimetres, and the height is 3 centimetres. Always take the time to check the question at this point to ensure that you've answered exactly what you've been asked for. Okay, so let's just check a couple of things. Can you think of any other words that might be used to ask for a minimum or a maximum? This question didn't use the words minimum or maximum. What steps do you take to find a maximum and minimum value? And in an exam, if you're having difficulty with that first part A, the proof, what should you do? Should you just leave the question and lose those whole 10 marks? So we are now ready to do exercise 6Q, and questions 1 to 6 are level C, and questions 7 and 8 are AB questions. We will also be able to do exercise 6R. We'll be spending a lot of time in class doing these questions together.